Yeah, good evening everyone. Sujana Camps, let's start off. So last class we have done with work power energy. I'll be sending you some practice sheets, of kinematics, NLM, friction, work power energy, circular motion. Not much, maybe I'll send you like 100, 120 questions for practice. So abhi major test are enough for people who have pace ka major test, you guys can give it. For others also it's a good practice. And plus next 2 weeks also the test I'm conducting is the same portion, your major test. So that should, I think, take care of it. So do focus on that. Make first thing, right, go through the notes and then start solving, all the papers that we have done. That should help. So today we'll start with ray optics. It's an easy chapter, right? And once we're done with this, again we'll get back to mechanics, centromas, and all that stuff. Ray optics has a decent weightage. Mostly the chapter, right, is based on formulas. If you know, there are two main things: sign convention and formulas. If you know these two, questions will go quite easy. Unlike mechanics, right, there's really not too much to think. So let's start off. Today we'll be doing reflection. Others, do keep your cams on. And the deadline is today night, geometrical for the test. So if you have not given, make sure to give. Ali, there is a test. I gave you a reminder now.
Thank you.
After 2 days, you will tell me, sir, I just forgot.
No,
After
sir,
giving reminder on the same day, huh?
I remember, sir.
Means you remember and you still didn't give the test. मतलब you're trying to go against the policy. ऐसा कुछ है. You're a rebel. We need you to send to Ukraine. Chalo. You can go to Russia also, we don't mind. Geometrical or ray optics. So what is this exactly? It deals with particle nature of light. Now, what is particle nature? We'll not get into this thing here. We will do that in more detail in wave optics. So all materials that have two types of nature. One is a particle nature, one is a wave nature. It deals with particle nature of light. Which explains phenomena like reflection, refraction, and formation of images. Formation of images. Right now, particle nature, wave nature, like I said, let's not worry about what is that right now. For now, just leave it like that. Because it requires a little more delay of explaining. We don't need it right now. Now, light, right, whenever it's traveling, it has few properties. First thing, light travels in straight lines. In homogeneous mediums. Means if the medium is uniform everywhere, it will go in a straight line. Uniform. So light rays don't bend, in vacuum and all, but if the medium is changing, it bends. So we will see that also later on called refraction. Next thing, light rays pass through each other. Without any interference. So if two light rays are, moving through them, they'll just pass through as if nothing happened. Just think of it. It is like if you switch on light in your house, if you switch on two lights, it doesn't mean the light will cancel out, no? You don't see that. The lights will just pass through as if nothing happened. That means, ever seen the Star Wars movie? These people fight with the lightsabers, buzz, 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 karke they fight. Big bullshit it is. That means actually when two lasers hit, what'll happen? They'll just pass through each other, right? You're not supposed to get that sound and sparks, isn't it? So that lightsaber ka thing you're fighting. And second thing, tell me one thing. When you switch it on, how does the light know how to stop it here? How does the laser know? अरे मुझे सिर्फ 1 मीटर तक जाना है. I should not go more than that. How does the laser know? How does it stop there? You're getting it. Star Wars is a big bullshit, but ठीक है. But Star Wars actually was an inspiration for telecommunication people, In Star Wars, when these people made in 70s and all, these people, it's a show, right? So they used to show this wireless communication, like what the earbuds which are using. So all these musical companies actually got inspired, like, yeah, can we do something of that sort? The mobile phones and all that thing, they're actually inspired by it. They had technology, but the inspiration was Star Wars. So certain things were taken from there. Certain things were like, yeah, still out of reach. And that lightsaber is one nonsense thing. Next thing is law of reflection and the law of refraction. And light also has a property. We call it Fermat's principle. What Fermat's principle says is the light ray always follows a path which takes the least time. Quite a useful concept. Which takes least time. Clear? Have a look at this. Displacement, not exactly, right? It's not displacement. Now, let's see, based on this Fermat's principle. So, if you take this law of reflection, let me just show you like this. Let's say we have a mirror here. Let's say we have point A here, and let's say we have point B here. So let a light ray go from, this is the mirror. So we want to find the shortest path from A to B. So this is how we do this thing. So let a light ray go from point A. Let a light ray go from A to mirror to B. Now we don't know how it will go, so let it be like this, and let it be like this. Let this angle be θ1, let this angle be θ2. You're getting it? Let's say, imagine you don't know law of reflection. You know only, Fermat's principle, that the light will always take the shortest time. That is the only thing that you know. So let the light ray go from A to B, it will hit the mirror at θ1 and it goes off, something of this sort. Now, if you take the distances here, let the distance between them be L. So from here to here is X. From here to here is L minus X. This is H2. This is H1. So time taken to go from A to B. Let's call this point C. Time taken to go from A to C to B will be AC by speed of light plus CB by speed of light. c is the speed of light. So we are trying to find the time taken to go from A to B, and we are trying to prove it the shortest time. So basically Fermat's principle. So this would be AC will be root over h1 square plus x square by c plus root over h2 square plus L minus x whole square by c. This is your time. For maximum minima, dt by dx is equal to 0. Now, if you differentiate this, you end up with 1 by 2 root h1 square plus x square into 2x. This is a c is there. Plus 1 by 2 root h2 square plus L minus x whole square. This will be 2 into L minus x into minus sign by c equal to 0. This thing turns out to be x by root over h1 square plus x square is equal to L minus x by root over h2 square L minus x whole square. This is nothing but sine theta 1 is opposite side by hypotenuse, and this is nothing but sine theta 2. Therefore, we get theta 1 is equal to theta 2. This is your law of reflection. That means whenever you send a light ray from a point A to the mirror, whenever it reflects, the angle will be always theta 1 is equal to theta 2. That will give you the shortest time always. L is the length between A and B, horizontal length, which is constant. Check it out. So you can actually prove law of reflection using Fermat's principle. Ever thought about it? How do you get theta 1 is equal to theta 2? We keep saying, na, in the law of reflection, angle of incidence is equal to angle of reflection. Why? There is a reason. It follows the property of the light. So whenever a light ray has to hit a mirror and go, it will always take the shortest time when the theta 1 is equal to theta 2. This principle is what we call as law of reflection. So this is the proof for law of reflection. Have a look at this, what he did. Do you guys remember this question? We did this in foundation.
Yes, sir.
A, B, the truck will go to the river, get water to B, find the shortest path. It was the same thing there. So we could have actually proved that using calculus, but foundation you don't know calculus. So clear? Any doubts on this? Next one. Law of reflection. So we have a mirror. This is your normal vector. This is your reflected ray vector. This is your incident ray. This angle of incidence, and this is angle of reflection. So the first one, angle of incidence is equal to angle of reflection. Second one, incident, reflected, and the normal are in the same plane. Incident, reflected, and normal are on the same plane and on the same side of the mirror. So, do you remember this thing? If three vectors are in a plane, what is the condition? Anyone remembers? If three vectors are in a plane, something happens. Something is zero. Anyone remembers?
Yeah, box product.
Cross
Box product.
Box product.
Box product. I cap, R cap, N cap is zero. This vectors, we did this thing in this was this thing, box product. This one. Page 173 vectors. Box product is zero. In case you're wondering what is box product, this is I cap cross R cap dot N cap. The box product is zero. Third, the relation between the reflected ray vector R cap is equal to I cap minus 2 times I cap dot N cap into N cap. This also you guys remember? This we did in dot product. If you have a light ray hitting a mirror, find the relation between IR cap and. This is page 149, question 25. We proved this in vectors. Definitely go back and check the proof. In case you're still confused, you can ask me next class. There, these are the relations. Like if I give you the unit vector, you can find the vector from there. Check it out. Clear? Great. Let's see a question. Any doubt so far? That's it. That is the only concept that I wrote you today. Law of reflection. Let's see a problem. We have a parabolic mirror. Y is equal to x square. This is your x-axis. You sent a parallel beam of light. So what will happen? This will go somewhere here, hit at point P. This will go somewhere here, hit at point Q. After hitting, this will bounce off like this. Let's call this thing P dash, and this will bounce off like this, let's say. Like this, Q dash. Let this length be X. This point here is X is equal to half. This is exactly at X is equal to half. This guy is exactly X is equal to 1. So matlab, this point P ka coordinates will be 1, 1. Q ka coordinates will be half, 1 by 4. Find X. So parallel beam hits the mirror and falls on the floor. Find the width of the that reflection. A parallel beam hits the mirror and falls on the floor. Find P dash Q dash. Hmm. Question is clear? Try. Diagram is not up to scale, okay? My diagram might not be the actual diagram. I just draw it roughly. Diagram may not be accurate. You have to draw a new diagram for your own. Try. You got 2 minutes. Any ideas? Can I do like this? Forget about the full light beam. Only for point P, find the position where it lands. Only for point Q, find the position where it lands, and then try to subtract it. And didn't we do something like this? Do you guys remember we did something like this? Do you guys remember this? Reflection. Then you hit the mirror at an angle that I is equal to R. This is how we get the coordinates. We have done this in calculus. Like I keep saying, you really don't learn new things. And then I showed you even for 120 degrees also. There we found the angle of, the thing, point coordinates I asked you to find there. Now I'm asking you to find the width. We have done these kind of questions in calculus differentiation way. Okay, I don't think so, but let's see. Show you. See. First, let's find for each point separately. First, let's find for this guy, the point P. So light ray comes like this. At this point, if you try to draw the tangent, the slope will be dy by dx. That would be 2x. And at x is equal to 1, the slope will be 2. Basically, this is the theta. and this is your normal. So after hitting here, this thing will bounce off and pass like this. So this is your P dash. Agreed? Now what I'll do for convenience, from this vertical line, if that is theta, this is 90. This is also theta. This would be 90 minus theta. This also would be 90 minus theta. This would be theta. I know this thing. Let's call this length will be how much then? What is this height? It's 1 comma 1, right? So this full length was 1. This length ka length is 1. So this guy would be did I get the angle right? नहीं वो थीटा नहीं होगा. This is a mistake.
सर ढूंढ दे रही को पता नहीं
that won't be theta. Wait, I did a mistake. वो theta नहीं होगा. This full angle is theta ना? If that is 90 minus theta, this is theta. That is 90 minus theta. Theta to 90 minus 2 theta. This should be 2 theta. How do I? I can do this in a much better way. This will be 180 minus 2 theta. This is 180 minus 2 theta. How did you get that? See, these are parallel lines, no? This line and this line are parallel. This angle and this angle should be equal, no? Agreed? Please check. They're alternate angles basically. This angle and this angle are equal. Anyone has a doubt on that? So now basically on that triangle which we got, this is P, this is P dash, this is 1 meter. I need to call this point something. Yeah, I'll just call this thing P double dash. And this is 180 minus 2 theta. So tan 180 minus 2 theta will be 1 by that PP dash. So P dash, PP dash. I'll just call it P1, P2. This is looking so weird. P1 and P2. 1 by P1, P2. So there. So P1, P2 will be 1 by tan 2 theta. And I know tan theta is half. What is tan 2 theta? 2 tan theta by 1 minus tan square theta. This will be 2 into 2 by 1 minus 2 into tan 180 minus 2 theta. No? Sorry, this will be minus 1 minus 2 square. So 4 by minus 4 by 3. Therefore, this guy would be 1 by 4 by 3, 3 by 4 meters. Check. Oof, so much work. Just geometry, everyone. Actually, second one अच्छा आएगा. I'll just show you that also. See, second one will come easy. The one who is hitting at Q, at this point, when you draw the tangent, slope is 2x, and here x is equal to half. We get slope is equal to 1. We get tan theta is equal to 1. Theta is 45 degrees. So this angle is 45. So this light ray actually goes straight. That point is actually Q dash only. Are you getting it? That point is Q dash only. And you found basically this Q dash or the P2, there is the same point there. So this point is actually P2. Then this was P1. No, wait, I did a mistake.
Sir, the slope will be -1, right?
No, P2, yeah, alag hai actually. Which one? Slope will be y minus 1?
So because it will be tan 135.
Y tan theta 1 ray, God. This is Q dash. This is half meter. This length will be, this was point P, no? This was P1 and this is somewhere P2. There, check it out. Tan 45, na, slope is tan 1. This length was 3/4 meter. And this length was how much? Half meter. Therefore, the answer is P dash Q dash will be 3/2 plus 1/2, 5/4 meters. Please check more of a geometry. Long one. Too much work is there.
Sir, can we do this like using mathematically like the reflection formula? Like
ये
the
सब
answer,
max ही है मेहन.
no,
Max, all this
without
is
the
max.
angles, without the angles.
Okay,
Like
कर लेना.
no, the answer comes the same. Because
Oh, normal vector क्या लिया आपने? Normal vector क्या लिया आपने?
what? No,
Use the
actually
formula, na?
what I
This
did
formula.
is
You did this
what
formula, right?
no. Without
Okay.
that, like what I did is in maths they give this in straight lines a formula. Whenever a point reflects through some, then I found the coordinates of the point, and then using distance formula I did it. A quadratic comes, but it has real roots. So then it's
ठीक है.
then
If you got
not
it, तो great then. I don't know max में ऐसा कुछ concept है, but ठीक है.
no in straight
Then-
lines.
If reflection के लिए कुछ है, भेजो ना मुझे. एक बार मैं भी देख लेता हूँ.
No,
But everyone
like
has got this thing.
when a point P, अच्छा.
भेजो ना भाई बोल रहा हूँ. Whatever you're saying, put it on a paper and send it to me.
Okay.
You said no, you got the same answer 5/4. So then it must be something good only. Let me check it out. Clear everyone? Next one. Do check it out. It's just geometry. कुछ नहीं है उसमें. Got the idea, na? Luckily, actually, the Q became straight, so it made your life easy. If that is also messed up, that would have been more tough. It's just a lengthy problem. Next one. Can I turn the page? Let's do one more like this. Let's say we have a spherical mirror. Radius is r. You're sending a light ray like this. It bounces and goes like this. Let this point be x. Let this point be P and let this point be A. And this height here is r/2. R is the radius of this thing. Find Px. This is the principal axis. Straightforward geometry, nothing else. I am not teaching anything new today. It is all that reflection ka tungal. You are just playing with geometry and angles. I hope the question is clear. You have a spherical mirror, meaning this would have been a complete circle. You took a part of a circle. The light ray goes, hits the mirror horizontally. So this is a parallel light ray. It's the point A at a height of r/2, then reflects and crosses the principal axis, the horizontal line. Find Px. Easy question. I hope is clear. Try. You got 2-3 minutes. Again, just geometry. Any answer? r/2. That is what you learned in school, right? That's what you studied in school. There is a spherical aberration. School mein na, you learn like, when a parallel light rays go and hit the mirror, they pass through the focus, which is r/2. There's an approximation there which we don't teach you in school. So that is wrong. Forget about all that nonsense. Solve. I'll give you a little hint. Maybe from there you'll get some angles. Try see. This is your center. So from the center, when you drop a line to the mirror, it's a normal. Isn't that what we call a normal? A line passing through the center, this thing. So if this angle is theta, this angle is also theta. So from here, if you drop a perpendicular, let's call this guy B. Now from the triangle ABC, A to C ka length is R. This guy is r/2. This angle is 30 degrees. So if this is 30 degrees, this also becomes 30. Because alternate angles. If that is 30, this is also 30 because I is equal to R. If that is 30, this should be 30 because total is 90. Hold on, plus 1/√3, 1 by... नहीं रहा बिना थोड़ा बड़ा आ गया तुझे. Now what to do? Now get it. There, I got you all the angles. अभी सिर्फ geometry बात है. Get px. R by 2 root 3. I think so. Something like that you get. तो उत्तरी तो आएगा. Now from this triangle, I can find cos 30 is BC by R. So we get BC is equal to R cos 30, R root 3 by 2. I also know CP is equal to R because that is a radius. Then if you take the triangle ABX, ये 30 था, ये R by 2 था. So BX will be tan 30 is BX by R by 2. So BX will be R by 2 root 3. Perfect. So what do you want to find? You want to find PX. So PX is nothing but CP minus CX. But what is CX? CX is nothing but CB minus BX. So CP is R, CB is R root 3 by 2, BX is R by 2 root 3. Take out R by 2 common, you end up with root 3 minus 1 by root 3. So this would be R minus R by root 3, that is 333 minus 1 by root 3. That will be 2 will cancel. R minus R by root 3. Please check your calculations. That's your answer. Root 3 R minus. So main thing is figuring out that the angles are 30, 30, 30. All three will come 30. Uske baad there is the geometry. Check it out. Anyone got this? Ronak, what is theta? That is the thing, no? You have to figure it out. For this thing, na, you can have a standard result. Huh? You can prove this. If you send a light ray at an angle theta, from the center, if you take this as theta, and if this is x, and this is p, the result, right, px will be r minus r by 2 sec theta. This you can mug it up. For any theta you can find. I gave you numbers. Yeah. Do check it out. Yeah, you can do with variables, yes. That's what you got. Next one. Clear? Any doubts on this? So what are all doing? Everyone is busy with that Garba thing. People are running, jumping, dancing in circles, circular motion. No? It's a non-uniform circular motion whose radius is changing actually. Isn't it? Something of that sort. Yesterday I was standing and I was watching people are dancing in circles. That's what I realized. The circle becomes big, the circle becomes small, the circle rotates. It does everything. It's an interesting thing. Next one. This is mirror 1, mirror 2. You center ray parallel to mirror 1. Find angle of deviation. What is the angle of deviation? Or I can say first draw the path of the light ray. And angle of deviation. Delta. So angle of deviation is nothing but the angle between the initial ray and the final ray. Nee, man. Aryan is sending secret messages to everyone. Focus on the class, right? You're threatening someone, at least threaten na with proper, confidence and threaten karna hai. Kya hai ye? Rahil is equal to Karthik, waste of earth resources. Who scolds people like this? क्या है ये मतलब इतना weird way of scolding. चलो forget it. Waste of earth resources. Who really gives a damn about earth ka resources? I really didn't understand though. Our chemistry teacher, when we are preparing, he used to scold people like that. He's like, hey, you, what are you doing there? Why are you behaving like fluorine? Always electronegative. This guy literally used to scold you like, using chemistry compounds. You're always behaving like that NO2, stealing electrons, not focus, always negative in life. Why are you behaving like that? Be like CH3 plus, be like O2 plus. It gives you electron, share, happiness. We used to think like, yeah, what is this guy trying to do? Teach or scold? Exactly. Kuch to clarity hona chahiye, right? Have a clarity, na? Are you scolding? Are you teaching? Be clear. Don't mix up both the stuff. He was dangerous, yaar. Sir ka name was Mohan Rao karke, chemistry sir. Was scary, yaar. The worst part with him was after the class gets over, he catches someone. He blocks the way and he just stands there on the way and keeps talking for 40, 45 minutes. The entire class is literally stuck inside. So we used to have a classroom like this. This is a door. So after the class gets over, he just used to stand there and talk to one person. All the other people are stuck. 45 minutes, everyone is looking at him. One day I got so pissed off, I need to go to washroom actually. So I just got up. I just pushed him and went away. He came running behind me. Hey, Arun, I need to talk to you, Gargi. He caught me somewhere here. All the people ran away like this. And all my friends got a brilliant idea. Why don't we send Arun every time end of the class? So that others can leave. So I was a goat sacrificed for some time. Hopeless it was. 120, 60. No, answers nahi hai. 120 kya? Could be right. Maybe I'm wrong. Any other answers? Yeah, 120 to nahi hai. 60 bhi nahi hai. I think you guys are drawing it wrong. Something interesting happens. You got a minute more. Focus, everyone. Try. But who is Rahil in the class? Right? We don't have any Rahil here. Hardik bhi nahi hai. Yeah. Looks like most of you are laughing. You guys people know someone. Oh, ठीक है रे. You hate someone. Why are you discussing about some guy who's not even here? See, if you hate someone, you should make sure they know, right? If you're taking revenge on someone, shouldn't they know that you are taking revenge? Or else that revenge will go into someone else's account. Doesn't make sense. क्या फायदा? Next time Instagram में post कर. Next thing. 300 degrees रौनक थोड़ा बड़ा आ गया रे. See now everyone, you guys are not getting the diagram right. This is the normal. This is 30. This is 60. Now, this is where the mistake happens. When you draw the array, you draw like this. Flow mein, meaning habit hai. This will be 60. This will be 30. If this is 30, 30, this angle should be how much? 120. 120, why are you drawing like this? 120 aisa nahi dikhega na. You're drawing an acute angle. 120 should look like this. This light ray is actually bouncing inside. This guy is bouncing inside. It's going to the left. It's not going to the right. This was 60 and this was 30. There. This was 30. This was 60. This is 120. Not 0. Right? Now, if I just magnify that again, so this light ray is coming and hitting at 120, meaning this angle is 30. So when you hit at 30, you'll bounce like this at 30. And this is given 30. That means this is 60. So this light ray will go and hit the mirror at 90. Isn't it? So the light ray hits the mirror at 90 degrees. And what happens when you hit the mirror at 90 degrees? It will retrace the path. This is an important concept. Huh? And the final diagram looks like this thing. See, the light ray comes like this, hits, goes and hits the mirror at 90 degrees. After hitting, it will retrace the path. It will go back the same way. Again goes back, hits, and again comes back this way. So what is the angle of deviation? This angle, na, delta is 180. When you take vectors, you have to take them tail to tail. This is also called as principle of reversibility. Basically, in this thing, I can make a statement here. If a light ray hits a mirror along the normal, it will always retrace the path. Doesn't matter. Let's say you keep 10 mirrors, 10 lenses, and finally, if you hit the last mirror perpendicularly, you'll go back the same way you came. If a light ray hits the mirror along the normal, it retraces the path. There. This can be also written as principle of reversibility. That means if you replace the source and the image position, you get the same thing. The light rays will still follow the same path. If object is placed in the place of image, image will form at the position of object. Previous position of object. So basically, image and object are interchangeable. Have a look at this. Quite a useful concept. We're going to use this extensively later on. Clear this, everyone? Next one. Next one. let's say we have a pole here of height h. On top of the pole, there is a bulb. Someone took a particle and
Can you show the
projected.
previous page?
Clear? So someone projected a particle with u and theta. So this thing goes like this and projectile is flying. So when the projectile is flying, you can see whenever this particle is somewhere here, this will be the shadow on the ground. This is the shadow of the particle, the shadow of the projectile on the ground. Now, find velocity of the shadow at time t. No need to calculate numbers. Just give me the process. You can just leave it in variables and leave it. No need to solve. Find time or find the maximum x coordinate of the shadow. Find the maximum x coordinate of the shadow, meaning this point is origin. You're getting now. After some time, what will happen? See, initially shadow will be here, then the shadow will be here, then the shadow will be here, then the shadow will be here. The shadow is moving. Shadow is continuously moving on the floor. I just want the equations. I don't want you to simplify. Numbers are bad. There's no numbers. So let's see. I just want you to see how you handle this thing. Find the velocity of the shadow at time t and find the maximum x coordinate of the shadow. I hope the question is clear. Anyone not clear with the question, please ask. Velocity. You just give me the process, like what you're doing. That's it. Just get the equations. Give it a try. I'll show you. मतलब give me something like what will you differentiate and वो differentiate करने के लिए under what quantities are there. Take a minute, then I'll show you. Then you can verify. Rehan, there in the class, focused. You look little lost. You're thinking about night garba. No. People play for 1 to 2 hours, no? And they don't eat also properly. It's kind of a weight loss program, something like that. Also, no. Today the medical ka batch is there, morning 7 o'clock. All were so tired, all were sleepy. I said, what the hell are you guys doing? So we are playing our. I said, do you get free food? No, you have to buy food also. Then I said, what's the point? I teach me you get a lot of free food. U cos theta. इतना chance रहा क्या रे? When we look at U cos theta, if you shine light like this, parallel beam. If it's a parallel beam, you would have got constant. See the steps. Let this be Z. So at this point here, this is X comma Y. What is X? U cos theta T. Projectile everyone. Y is equal to U sin theta T minus half GT square. What? You thought kinematics won't come in optics? Half GT square. So you know X and Y ka values. So if you take this guy, this would be X and that is Z. This is H and this would be H minus Y. Similar triangles. If you take this angle some alpha, tan alpha will be Z by H is equal to X by H minus Y. There, Z aa gaya na? Z is X into H by H minus Y. So what's the velocity of the shadow? dz by dt. You can just leave it here, only to simplify. So you can differentiate this guy x h by h minus y and substitute x and y ka value. That's the velocity of the shadow. The rate of change of set coordinate. Can someone tell me when you'll get maximum x coordinate? When this guy is flying and this was the bulb. Think about it. See what is happening here. Huh? Initially shadow is here, 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 shadow is here. Then once you start coming back, again shadow is here, again shadow is here. Are you getting it? Shadow will decrease. So you get the maximum x coordinate when the light ray becomes a tangent to the parabola. When the light ray becomes a tangent to the parabola, this is the farthest point the shadow will go, isn't it? Because after that it will come back again. Is that making sense? That is the farthest point. Now we have to use a little maths and prove that, but fine, leave it. Light ray becomes tangent to parabola. This would be your max x coordinate. Check. Why will it come back? Are finally shadow kahi pe hoga? Here na? It came back, right? Or maybe the diagram is not looking that intuitive to you. Imagine if I throw something like this and light bulb is here. So shadow is here, shadow is here, this shadow is here, this shadow is here na again. Papas aa rahe hai na? So the shadow actually goes front and shadow comes back. So at this point the velocity is 0 also. So at this point velocity of the shadow is 0. You can prove it like that also. Because it is turning back. So exam they can ask this question also. The shadow goes front and comes back. The shadow always goes in the forward direction. Goes ahead and then comes back. Check. Clear, everyone? Next one. Let's say we have a mirror. This is XY plane mirror. This is YZ plane mirror. You're sending a light ray, which is I plus 2J plus 3K. So then this will hit the mirror, bounce, and then hit the mirror and bounce. Find the vector of the final ray. Find the final ray vector. Try. How do we? This is an easy one. This is something like main sky easy question. -1, -2, -3. Near Adrat. Others, any answer? -2J -3K. Okay. Now see, the catch here is whenever you hit a mirror, only the component perpendicular to the mirror will get reversed. When a light ray is hitting the mirror, this is the perpendicular component and this is the parallel component. The perpendicular component or the component along the normal will reverse. So in our question here, when this guy is going like this, this is XY plane. So here the normal is Z axis. Here it is, this is a YZ plane. So this is X axis is the normal. So when you go and hit here and bounce off, so this is I plus J, I plus 2J plus 3K. Only the Z ka component will reverse. So this guy will become I plus 2J minus 3K. And then when you hit this surface here, only the I component will reverse. So this will be minus I plus 2J minus 3K. That's your answer. Check. Right, Ronak Naranjan. So whenever you hit a mirror, only the component perpendicular or along the normal, that component will reverse. Everyone else will remain same. Please check. Easy one. Clear? Easy? Next one. This is a standard result. Suppose if you have a mirror and you're sending a light ray. This is the incident ray. This is the reflected ray. And you rotated the mirror by angle theta. If mirror rotates by theta, keeping the incident ray same. Meaning the diagram would something become like this. So the mirror would have become like this. You rotated this by theta. And you kept this ray same only. So the reflected ray will bounce off. Find the angle rotated by the reflected ray. Have a look at this video. Hmm. None? Find angle rotated by the reflected ray. This is a standard result which you need to remember, but try and get it. Keeping the incident ray same as in matlab initially this ray and this ray are exactly the same one, meaning same angle. Yeah, get it easy on the standard result. Try it, take a minute. See. So this was your normal. It is 2 theta. You're right. This was the reflected ray. So let this be I. This is also I. Now when you rotated this, so the normal becomes like this. You kept the light ray same. So this angle becomes I plus theta. So the reflected ray becomes I plus theta. So initially, what is the angle between incident and reflected ray? Angle between incident and reflected ray was 2i. Now what is the angle between incident and reflected ray? And remember, you're keeping the incident ray same. is 2y plus 2 theta. So what is the difference? 2 theta. This is the angle rotated. Check. Easy one. Standard result. Do keep this in mind. Any doubts on this? Please ask me. Can I turn the page? Adrit, Mehan, Palaksh, clear with this? Udyan, clear? Neil, Kartika, Anika, got this thing so far. Swastika, Maulika, all clear so far? Easy stuff. I think, and it's a little basic. Next one. We have a observer here. There is a mirror whose width is 2D, and at a distance d, there is a person at a height d. And at a distance d again, we have a road. So we have a vehicle there. The vehicle goes with constant speed u. Particle moves with constant speed u along the vertical line. Now, this person standing here, the question is, for how long can he see the image of the particle? For how much time? So this thing, particle is traveling from minus infinity to plus infinity. For how much time can he see the image in the mirror? Question is clear? Did you ever notice this thing when you're sitting in the auto, right? If you sit in some position, you can see the driver. If you shift to the little, you can't see the driver. That means depending on where you sit, you can see the driver. Doesn't mean driver vanished, right? He's still there. The light rays are not reaching you. So the question is, if this thing is going here, mirror is only 2D ka length. For how long does this person see the image of the particle? I hope the question is clear. D by 3U. Aryan, you're wrong. Anika, you're wrong. Adrit, I think you are right. Let's see. So the thing is, see, always go the reverse way, okay? Always go the reverse. If you send a light ray from the man to this corner, and if it goes here, that means when the particle comes here for the first time, he will see the image, isn't it? And similarly, if you send a light ray to this corner of the mirror, and when it hits and goes off here, this is the last time you will see the image, isn't it? This here is called field of view. Means you can see any image only if you stand in that region. So this angle, if you take it as alpha, this will be alpha. If I take this angle as beta, this also will be beta. And we can see from this triangle here, tan alpha is equal to tan alpha was d by d. Alpha is 45. Whereas tan beta is d by 3d, which is 1/3. So I'll just call this point A here. So this point will be A dash. I'll call this point B here, and this point will be B dash. And let's call this point C. So tan alpha will be A dash C by AC, and tan alpha is 1. So A dash C will be 3D. Tan beta will be B dash C by BC, which is 1/3. So B dash C is D by 3. Therefore, A dash B dash, that is a field of view, will be 3D minus D by 3, which is 8D by 3. So time taken will be A dash B dash by speed U, 8D by 3U. Check. Right, Ranika. Adrit, you both got it. Check your calculations. It's called field of view. You cannot see the image wherever you want. You can see, you always have to choose the two, edges of the mirror, see the light rays, and then finish it off from there. Clear, everyone? Do check this out. Great. Now, that is one thing. The next part is the position of an object and position of an image. I think that we'll do in the next class. Like I said, I know ray optics is not there for your major test, so we will take a little slow for this week and next week, and then we'll again go again as usual. Okay, with this we'll wrap up for the day. Right? Any doubts, anything, you can stay back and ask. Also free to leave. So next class when we meet on Friday, we'll continue from here. We will finish off at least the mirrors part by next week. So next week we'll have only one class on Wednesday, and Friday it will be just a doubt solving session. So those who have doubts can send it before Thursday. So I'll give you a slot. As usual, like I won't call all of you like a fish market and doubts will be a mess. If you send me your doubts, I'll give you a time slot and you can come for your doubts and finish it off. Next week we can do that. But today, tomorrow maximum, I'll send you some sheets for your major test practice, and others also should do them because it is a combination sheet of all the chapters you have done so far. Ray optics is easy, but first of all, do finish off your work per energy ka backlog. And the test is today, deadline 11 o'clock. So make sure to give if someone has not given. Okay, that will wrap up for the day. So any doubts, anything, stay back and ask, or else you're free to leave. So take care, stay safe. I'll see you on Friday again.